The properties and methods we have written this far have been what are called instance members. They belong to an instance or an object. They don't belong to the class. Now that might be a little confusing because our person class defines a first name property, but we cannot use that first name property unless if we use it from an object of person. So on line 15, I've created a person object called John. And then, and only then, can we use that first name property. So if we wanted to, we could create a variable called name, and then use the first name property to assign that value to the name variable. But notice that we can't replace John with person, because the person class doesn't have a first name property. The objects of person do, but the class itself doesn't. So there are times when we want to define a property or a method that belongs to the class. It doesn't belong to an object. And we call these type of members static members. And we have used static members before. Just by opening up our person class. If we look inside of the constructor, we have used string dot is null or empty, and string dot is null or whitespace. These are static methods. They belong to the string class, not to a string object. In fact, if we try to use either of these methods, they aren't listed in IntelliSense, and that's because they are not instance methods. And let's look at some examples as to why we would want to use static members. Let's look at a string, because that's kind of simple to do. So let's first look at the length property. The length property gets the length of characters within the string. So it needs access to the individual characters so that it can count them and return the amount of characters within that string. That would be a little hard to do without having access to the data contained within the string object. So in contrast, let's look at is null or empty. We pass it a value, a string value in this case. And the is null or empty method doesn't need access to any of the internal data of the string object. It just needs to look at the value, which is stored in memory. So it looks at its value, determines if it's null or empty, and then returns true or false based upon that value. So it all comes down to, if we need access to internal data, then we want to use an instance property or method. If we don't need access to that internal value, then we can define a static property or method. And today we are going to write some static methods. We aren't going to write static properties because they follow the same pattern. We're also going to look at how to write static classes, which is a special kind of class, kind of like abstract was special. Static is special in its own way, in that everything within a static class has to be static. So we'll get to that in a minute. But first, we are going to use the shape classes that we wrote a couple of days ago, but I did make some modifications to them, and before we get started, I want to show you those changes. The first is inside of the shape class. I added a protected field called _sides. This is going to contain a value of the amount of sides the shape is going to have. So for example, a square has 4 sides, so we would assign 4 to this field. I also implemented a virtual property called sides. I made it virtual just in case if we need to override it inside of a derived class. But since we have the data available to implement this property, I went ahead and implemented it by returning _sides. And if we look inside of square, I just made one minor modification by setting _sides the value of 4. For the sake of this demonstration, we also need another class. So let's create one, add class. We're going to call this circle. And I actually already wrote this class. I'm just going to paste it in. And it's inheriting from shape. A circle has a radius, so we have a property for the radius. The constructor is getting that radius value and assigning radius to radius. the underscore sides field is set to 0. Now, of course, you can get a different answer for how many sides does a circle have by the amount of people you ask, but you're typically going to hear infinity, 0, or 1. It's really irrelevant for this particular discussion, so I just chose 0. And then to calculate the area, we have taken math.pi. By the way, math is a static class. Isn't that cool? And then radius times radius. So we have our circle class, and now we need to write a static method. And the static method we are going to write is going to determine if a shape is a polygon or not. And to write a static method, we essentially write a normal method except for one little detail. We specify static. So we have the accessibility modifier, public, followed by static, then the return type, Boolean, and then the name of the method is polygon. This is going to accept a shape object, so we'll specify shape. And then we have our static method. Now, of course, we're not doing anything inside of this method yet, but we have defined a static method. It's important to note that we do not have access to the area, sides, or underscore sides, because these are instance data. And inside of the static method, we cannot access instance data. So if we try to do that, we can't do underscore side, we can't do area, and naturally, we won't be able to do sides. So inside of a static method, we cannot access instance properties or methods. So keep that in mind. But we do have access to the shape object passed as an argument, and we can get that data through that argument. And we have a kind of special case here. We can access underscore sides. Even though it's marked as protected, we have access to it because the isPolygon method is listed inside of the shape class. So because of that, it has access to underscore sides if we ever needed access to that. Okay, so this method is going to be really easy. We just need to make sure that the provided shape has the amount of sides greater than or equal to 3, because a polygon has at least 3 sides. So if we try to use this within our code, let's go to program.cs. Let's get rid of this code and let's create a square. We'll give it a side length of 10. Let's also create a circle. New circle. We'll give it a radius of 10. Why not? And then let's do console.writeLine. Shape is polygon square. We should get true for that. But let's do the same thing, but call circle. And we should get false for that. And by the way, console is a static class no, it's not a static class. It's a class that has a static method. No, it is static. I apologize. So console is a static class as well. Okay, so let's run this code, and there we have it, true and false. Square is a polygon, circle is not. So that is how to create a static method. And if you were going to create a static property, you would do the same thing as you would any other type of property, except you would specify static. So now let's create a static class. Static classes are frequently used as utility classes, like the math class that we used earlier. It's a utility class that gives us utilities to perform math calculations. It gave us the pi constant, and there's a few other tools that we can use from the math class. So in our demonstration today, we are going to create a static class that is going to be a utility class for shapes. We are going to move this isPolygon method outside of shape and define it inside of that shape's utility class. Now, it makes sense to really put it in either of those places, but for today's demonstration, we will just cut it out of our shape class, and we will create a new shape utility class. And we do so the same way we have created every other class. Call it shape utility, but the only difference is we say that it's static. And there are 3 important rules that static classes must follow. In fact, our code is not going to compile if we try to break any of these rules. The first rule is that anything we define inside of a static class has to be static. So any property, method, or field has to be static. The second rule is that we cannot create an instance of a static class, and that makes sense because there is no instance information whatsoever. Everything is static inside of a static class. The third rule is that we cannot inherit from a static class. That too makes sense because there's nothing to inherit. You inherit instance information. You don't inherit static information. Okay, so we have our static class created. Let's just paste in our isPolygon method, and we are essentially done with this class. Now, one thing I do want to point out, remember when this method was inside of the shape class, we had access to the underscore side field whenever we used shape. We don't have that access anymore because now this method is outside of the shape class. That field is hidden because it's marked as protected. So we don't have access to that, but we really don't need access to that because the sides property gives us the same value. So let's go back to our program.cs and let's change shape to shape utility. And then the red squigglies will magically go away. And if we run this code, we will get the same results. True for a square, false for a circle. And that will finish today's lesson. Static members and static classes are extremely easy to write and use. You just need to remember that static anything cannot access instance data. So with that, have a good one.